Have you ever looked up at the night sky and wondered what secrets it holds? We often think of space as silent and still, but it's actually buzzing with activity, full of strange and powerful objects. Today, we're going to tell a story about one of the most incredible discoveries in modern astronomy. A story that begins not with a grand explosion, but with a tiny, persistent blip on a piece of paper. It's a tale of a dedicated young scientist, a mysterious signal from deep space, and a discovery that would change our understanding of the universe forever. This story takes us back to November 28th, 1967. At the prestigious Cambridge University, a brilliant and determined graduate student named Jocelyn Bernal was hard at work. She wasn't just any student. She had spent the last 2 years physically helping to build a massive new radio telescope. Imagine that, not just analyzing data, but actually swinging a sledgehammer and connecting miles of cable to construct the very instrument she would use for her research. This telescope, spanning over 4.5 acres, was designed to study quasars, which are incredibly distant and bright cosmic objects. Day after day, Jocelyn would painstakingly analyze the data that came pouring in from the telescope. This was the era before powerful computers could do all the heavy lifting. The data was printed out on long rolls of chart paper, and it was her job to visually inspect every inch of it. We're talking about nearly 100 feet of paper every single day. It was tedious, meticulous work, requiring an incredible amount of focus and patience. Most of the charts showed the usual cosmic noise, the faint whispers of distant galaxies. But one day, something caught her eye. It was just a tiny, quarter-inch smudge on the chart paper. They called it a bit of scruff. It was an anomaly, something that didn't look like the usual signal from a quasar, nor did it look like simple radio interference from Earth. It was different. Most people might have dismissed it as a glitch, a faulty wire, or just random noise. But Jocelyn Bell was not most people. Her scientific curiosity was piqued. This little bit of scruff seemed to appear consistently from the same patch of sky. What could it be? She brought the strange signal to her supervisor, the renowned astronomer Anthony Hugh. Initially, he was skeptical. He thought it was likely man-made interference, perhaps from a faulty car ignition or a ham radio operator. But Jocelyn persisted. She kept tracking the signal, and she realized it was far too precise, too regular to be random noise. It was a pulse, a sharp beep of radio waves, repeating with astonishing accuracy every 1.33 seconds. Tick, 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 like a cosmic clock. The regularity was so perfect, so unlike anything they had ever seen from a natural celestial object, that they started to consider a more exotic explanation. Half-jokingly, they labeled the source LGM-1. What did LGM stand for? Little Green Men. For a brief, thrilling moment, they had to seriously entertain the possibility that they had stumbled upon a signal from an intelligent extraterrestrial civilization. Could this be a beacon? A message sent across the vastness of space? It was a wild idea, but the data was so strange that no possibility could be immediately ruled out. The team was sworn to secrecy as they tried to figure out what they had found. Jocelyn went back to the data, searching for similar signals from other parts of the sky. If it was a civilization, were they signaling from elsewhere? And then, just before Christmas, she found it. A second signal, coming from a completely different part of the galaxy, pulsing at a different, but equally regular, rate. And soon after, a third and a fourth. The discovery of multiple signals made the Little Green Men hypothesis much less likely. It was highly improbable that multiple alien civilizations, scattered across the cosmos, would all decide to signal Earth at the same time, using the same method. The answer had to be natural. But what kind of natural object could produce such a perfect, rapid pulse? The team had a puzzle on their hands. The solution would come from a theoretical idea that had been proposed decades earlier but had never been proven. The theory involved one of the most extreme objects in the universe, a neutron star. So, what is a neutron star? Imagine a star, much more massive than our own sun. At the end of its life, it doesn't just fade away, it goes out with a bang, in a cataclysmic explosion called a supernova. The explosion is so powerful it can outshine an entire galaxy for a short time. While the outer layers of the star are blasted into space, the core collapses in on itself under its own immense gravity. This collapse is so extreme that protons and electrons are crushed together to form neutrons. What's left is an object of almost unimaginable density. Picture this: a star with more mass than our sun, squeezed into a ball just about 12 miles, or 20 kilometers, in diameter. That's about the size of a city. A single teaspoon of neutron star material would weigh billions of tons, as much as a mountain. They are the densest objects in the universe, second only to black holes. And here's the key part: just like an ice skater spins faster when they pull their arms in, a collapsing star spins faster as it shrinks, a lot faster. Some neutron stars can rotate hundreds of times per second. As they spin, they emit powerful beams of radiation from their magnetic poles, like a lighthouse. If that beam happens to sweep across Earth as the star rotates, our radio telescopes pick it up as a regular, repeating pulse. Jocelyn Bell Burnell's bit of scruff was the first ever detection of one of these cosmic lighthouses. They had discovered a pulsar. The name is a shortened form of pulsating radio source. The mystery was solved. The little green men were, in fact, rapidly spinning, super dense, dead stars. This discovery was monumental. It confirmed the existence of neutron stars, which until then had only been a theoretical concept. It opened up a brand new field of astrophysics, allowing scientists to study the laws of physics under conditions of extreme gravity and density that are impossible to replicate on Earth. Pulsars became incredible tools for testing Einstein's theory of general relativity and for mapping our galaxy. The discovery was so significant that it was awarded the Nobel Prize in Physics in 1974. However, the prize was given to Anthony Hewish, Jocelyn's supervisor, and another astronomer, Martin Ryle. Jocelyn Bell Burnell, the graduate student who first noticed the signal, who fought to have it taken seriously, and who did the crucial analysis that led to the discovery, was left out. This decision has been a topic of debate and controversy in the scientific community for decades. Many felt that her contribution was not just important, but absolutely essential to the discovery. Over the years, however, Jocelyn Bell Burnell's role has been increasingly recognized and celebrated. She has received numerous other prestigious awards and has become an inspiration for women and young scientists everywhere. She herself has handled the situation with incredible grace, never showing bitterness, and has instead used her platform to advocate for greater diversity and inclusion in science. Her story is a powerful reminder that science is a human endeavor. It's about curiosity, persistence, and sometimes about noticing a little bit of scruff that everyone else might overlook. It shows that groundbreaking discoveries don't always come from a single eureka moment, but from hours of dedicated, patient, and often unglamorous work. The next time you gaze at the stars, remember the story of Jocelyn Bell Burnell and the cosmic lighthouses she revealed to us. The universe is full of wonders, just waiting for a curious mind to find them. Thanks so much for watching. If you enjoyed this journey into the cosmos, don't forget to hit that like button and subscribe for more stories from the history of science. Let us know in the comments what other scientific discoveries you'd like to hear about. See you next time.